This is Sharika, UA14CS 122. Today, me and Stacy are going to explain evolution of this types of RAID, file system, and types of storage technology. So first, let's see about the evolution of storage devices. So the first was the magnetic tape, then cassettes, then floppy disk, then hard drive, CD, DVD, USB, Blu-ray, and now we are currently using cloud and hard disk. So these are the various components of hard disk. We have the cover assembly followed by the basket cover, the disk stack assembly, the DC spindle motor, the base assembly, pad insulator, and printed circuit. So these are the various components of hard disk, and these are the various types of connectors. So we have a 40-pin connector, a 50-pin, a laptop desktop SATA, which is 7-pin, laptop ID PATA, which is 44-pin, or PATA, which is 40-pin, and SCSI 80-pin, 7-pin, 68. So these are the various type of connectors we can use. And now let's see about the various types of RAID. There are various RAID levels: RAID 0, RAID 1, RAID 5, and RAID 6. We are going to see about these here. So first is RAID 0. RAID 0 is also called striping. That is, the data is striped across two disks. So the thing is, the advantage here is the write takes place very fast, and because it has to be written only once, and it can also be read fast. But the problem is, if there's a disk failure, then the data cannot be retrieved. Then RAID 1 is nothing but mirroring. The write takes a bit of time because it has to be written across two disks. Read is fast because it reads from one disk, but the advantage here is, even when there is a disk failure, it can be retrieved. RAID 10. RAID 10 is mirroring with stripping. So in individual, first the data is mirrored and then it is stripped. RAID 5. RAID 5 is independent disk with distributed parity. So here there are parity bits that are distributed across the drives. And then RAID 6. RAID 6 is independent array with double distributed parity. So in Karunya we use RAID 5, and for highly secure data we use RAID 1. So Stacy will continue from here.
Hello, this is Stacy Thomas, your freaking CS002, and I'm going to be explaining file system and storage technologies for Ism Assignment. So in this, first I'm going to explain what Karunya has. So Karunya has FC SAN IBM fiber optic cables. These are used for long distance and for the connections between hostels, and then uses for SAS it holds 1.2 TB, and it stores for a while and moves through SATA cables. And then it also has an IP network, which if 100 meter has a loss of data. So I'm going to go through file system, and in this the difference between Windows and Linux file system. In Linux it moves through directories, home user variable, and the disk partitioning is different for Linux and Windows. Over here we use drives. As you can see in this, it's C drive, D drive, E drive. So that would be the difference between Linux and Windows. And some file systems used in Linux file systems are a BFS, boot file system, compact disk file system, second extended file system, third extended file system, hierarchical, and then a high performance file system and a CD-ROM file system. So a distributed file system, it stores and accesses files based on the client-server architecture. So the client sends the message signal, and then the retrieval goes to the server, and then the server sends back the response. The data is accessed and processed as if it was stored on a local client machine. And then the distributed file system with data is stored on a server. So in this example, the process description, the user sends from New York to a server in New York. So the client computers access the first server in their referrals, and then similarly over here, the user in London sends the message to the server, and there is a DFS replication, so there is no loss of data, and then the retrieval comes back to the user in London and to the user in New York. So types of storage technologies are DAS, SAN, and NAS. So in DAS, direct attached storage, there is a LAN, and so everything is the client and server are directly connected to one another through this network. And in NAS, the server, client, and NAS are connected. It is connected using a switch. So between the server and the NAS, there will be a switch which is connected to for the retrieval of the data. In an integrated NAS, there's an IP. So the IP is used between the client and the NAS device. And then in a gateway NAS, similarly as above, there is a IP between the storage and there's between the client, as well as there's a NAS head and an FC-SAN network as well. So these are the networks that are used for a gateway NAS. In a storage area network, there's clients and server. So between the clients and the server, we have the LAN and the Ethernet switch, which connects the clients to the servers. And then there is an FC switch to the storage area. So between the server and the storage database, there is an FC switch which is connected, and there is a ISCSI target between the client's Ethernet switch and the server, and this is also connected to the ISCSI target, and this is all connected through a LAN. So types of SAN connection. Over here we have servers which are attached to the storage arrays. Now in order to get access to the storage arrays, the server has to go through a hub, and depending on if there are more servers, there will be more switches. So here it's a single server to a storage array, and there's just one hub. And then if the servers and storage arrays increase, similarly there will be a increase in switch, and the hub will remain. So we see an increase in switches depending on the number of servers and storage arrays increasing. The SAN interconnectivity options, there are tiers. So each tier consists of the first tier 1 consists of FC switch, tier 2 consists of director, and tier 3 consists of FC switch. So the directors are connected to the tier 3 FC switch and the tier 1 FC switch. This is like a hierarchy from switch to director to switch. So why do we use service for hypertext transfer protocol, for file transfer protocol, domain name systems, for simple mail transfer protocol, post office protocol 3, and we use it for internet messaging access protocol and for file sharing, as well as Microsoft servers, message block, print services, dynamic host configuration protocol, and for firewalls. So cloud storage consists of file storage, object storage, and block storage. And the data is stored as files and folders. It is used mostly on SMB and NFS, and it stores data in a hierarchical structure, as we saw earlier. And examples would be Amazon EFS, Azure File Storage, and Swift. The object storage manages data as blocks within sectors and tracks. Examples are IBM Spectrum Scale, Dell EMC, Ceph, and ExtremeFS. and it is highly available. It is the comparison across the entire data set. It consists of the entire data set is held with this. The block storage, each block acts as an individual hard drives, accessed by FCOE, ISCSI, and it's used to store individual file systems and databases. So this is the end of the assignment ISM.